Okay, we are back again. So I will be discussing the three important parts of this demonstration. The first one is the NEM features, the second one is the platform I used for this project, and the last one is the IoT device. So let us go to the first part. So NEM blockchain has five key components, which are the account, the namespace, the mosaic, the messaging, and the multi-signature. And on this simple demonstration, we are going to use all of them. So the first one, the account. So we have created several name accounts. So we have account for the IoT device. We have an account for the admin, which is also a multi-sig account, and the accounts for the co-signatories of this multi-sig account, and one client account. For the account of the IoT device, this is just a normal account. For the account of the admin, so this holds the key that is needed for the IoT device to execute the command. So this key can be distributed to those clients' account that you will allow to execute the command. So the second one is the namespace. So namespace is unique and does not have any duplicate in the NEM blockchain. Therefore, we can create a unique namespace that this IoT device will only listen to. The key mentioned is a mosaic that will be distributed to the accounts that will be allowed to send commands, which is the client account. So this mosaic is always tandem with namespace. You can create many mosaics with the same name. So if the IoT device will only look for the mosaic, anyone can execute the command as long as it finds the name key on the transaction. Therefore, we need the namespace so we can identify which one is a legitimate transaction. The namespace is house name and the mosaic is key. For the command initiator, this is an account that is a cosigner of a multi-sig account, which is this account. And this multi-sig account will be used as the trigger for the command, which is a multi-sig transaction. So this account will send this mosaic to the client account. So the key is not transferable to others. Therefore, only the first recipient, only the first recipient will be able to use the key, but this key can be returned to the admin. So a multi-sig transaction will be initiated upon selecting action, and this transaction holds a message that the IoT device will be listening to. So in this first part, we have used the five key components of the NEM blockchain, which is the account, namespace, mosaic, messaging, and multi-signature. Okay, now we move on for the second part, so which is the platform. So we have here two actions, which are the lights on and blinker on. Then we have here a text field. So this text field is where the name account will be entered. So if you entered a name address and click an action here, a certain validation will be made before it proceeds. So the first validation is to check whether the address is valid. So the second one is to check whether the account holds a certain mosaic named key and with the namespace house name. So if the account doesn't hold this key and namespace, therefore it is not allowed to issue the command. And if there is a key found, the multi-sig transaction will be initiated by the command initiator account, and the command will be attached to the message and will be sent to the IoT device. Okay, for the third part, the IoT device. So we are going to use this Raspberry Pi 3B Plus. So the OS we install here is a Raspbian Stretch OS. Then we install the Node.js, which we are going to use to run a script that will monitor for the transaction. So we configured its pin so that we know which pin we are going to use to light the LEDs. So since we have two actions in the platform, which is the lights on and blinker on, in which we use three LEDs, therefore we are going to use three pins from this device. So for this script, we are just going to use JavaScript as it is the simplest way to do demonstration. But we can also use different language like Python, but today we are just going to use JavaScript. So Node.js will act as the server of this device, and the contents of this script is just a simple listening script or looping to check whether this device has an incoming unconfirmed transaction. So it if it finds an incoming transaction, it will check the contents of the message if it has the command needed to light up the LEDs. So if it meets the requirements, then the IoT device will supply the power to the pin where the LEDs are connected and then light it up. Okay, so these are the basic configurations of this IoT device. So basically, it's just a looping of this function, which is the unconfirmed transaction. So this is the API call for the NEM blockchain, which listens to the incoming transaction on this IoT device. And of course, before all of this happens, the platform and the IoT device needs to be connected first to the internet, as this NEM blockchain transaction requires an internet connectivity.